Prior to discussing the announcement, it is essential to comprehend what particle accelerators are. The Large Hadron Collider, LHC, which CERN operates, is a 17-meter-long superconductive magnet ring and the world's largest and most powerful particle accelerator. It represents humanity's pinnacle of scientific achievement, powerful enough to recreate the conditions at the beginning of the universe. But could this apparatus be used to unlock the secrets of the universe? Could it hold the key to something far more ominous? CERN, established in 1954, is regarded as one of the most reputable research institutions, with 23 member nations and thousands of scientists working together. The LHC is its flagship project, but it is only one component of a vast network of accelerators and experiments. Imagine a racetrack, not for cars or horses, but for subatomic particles racing against the clock. The LHC accelerates protons in a vacuum, sending them on a collision course at nearly the speed of light. These collisions mimic the universe's energy conditions at the time of the Big Bang. The resulting temperatures are millions of times hotter than the core of the Sun. Thousands of magnets guide the proton's journey, while intricate cooling systems maintain temperatures colder than outer space. Inside the LHC, proton beams collide at 4 specific points around the accelerator ring, aligning with the positions of 4 particle detectors: ATLAS, CMS, ALICE, and LHCb. Each detector has a unique role in investigating various aspects of particle physics. Together, they act as enormous cameras, capturing images of these collisions. Scientists then sift through the debris, searching for signs of the elusive Higgs boson, also known as the God particle, and other phenomena that provide clues about the fundamental building blocks of the universe. By studying the microcosm, we gain insights into the entire universe. However, with every answer comes a new question, and each discovery presents new challenges. The LHC is more than just a scientific tool. It exemplifies human curiosity, innovation, and our unwavering pursuit of knowledge. It helps us comprehend the fundamental forces shaping our universe. Yet, as we push the boundaries of our understanding, we must also consider the ethical and existential concerns that arise. Could our quest for knowledge inadvertently unlock forces we cannot control? In the halls of CERN, where the limits of human understanding are constantly tested, a new revelation has come to light, one that has left even the most seasoned scientists intrigued. Brian Cox, a former CERN researcher and a leading voice in the field of particle physics, recently made an announcement that has both frightened and fascinated the world. His words resonated with haunting clarity. The goal of the Large Hadron Collider is to recreate a miniature Big Bang. That's right, a miniature version of the very event that created our universe. Cox elaborated on the implications of this objective, highlighting the LHC's remarkable potential for discovery. This includes unlocking the secrets of the Higgs boson and exploring dark matter, the mysterious substance that makes up a significant portion of the universe. Imagine holding the power of creation in your hands, the ability to summon the very essence of the universe. It's a tantalizing prospect, but also a dangerous one. The miniature Big Bang is not just a theoretical concept, it is an observable reality at the LHC. The temperatures, pressures, and raw energy within it mirror those of the universe's infancy. It's like witnessing the dawn of existence itself. But with such power comes great responsibility. A hypothetical scenario looms: what if something goes wrong? In fact, something did go disastrously wrong in 1978. Russian physicist Anatoly Bugorsky experienced an event that forever altered his life. While working at the U-70 synchrotron at the Institute for High Energy Physics in Protvino, Russia, he accidentally placed his head in the direct path of a proton beam. The beam, carrying an unimaginable force, entered the back of his head and exited through his nose. Bugorsky's experience was otherworldly. He saw a flash brighter than 1,000 suns but felt no pain. The beam burned through tissue and bone, leaving a trail of destruction. Despite this, he remained conscious and even walked to the clinic for treatment. The repercussions were both horrifying and fascinating. He suffered localized tissue death, partial hearing loss in one ear, and facial paralysis. Yet, astonishingly, his cognitive abilities remained intact, and he continued his scientific career. This incident is more than just a personal tragedy. It is a cautionary tale, a stark reminder of the immense power and potential dangers of particle accelerators. The risks associated with facilities like the LHC should not be underestimated. One of the most alarming concerns regarding the LHC's experiments is the possibility of creating a microscopic black hole. A black hole is a region of spacetime with such immense gravity that not even light can escape. These cosmic vacuum cleaners lurk in the universe's shadows, consuming entire stars. The mere suggestion that the LHC could generate even a tiny black hole is shocking, to both laypeople and professionals alike. Could such a black hole grow uncontrollably, swallowing the Earth? Despite assurances from CERN researchers that any black hole created would be unstable and evaporate almost instantly, the possibility alone has ignited debates, fears, and awe. Understanding how the LHC might produce a black hole is crucial to grasping the true extent of its capabilities, and the risks it may pose. To understand the potential creation of a black hole at the LHC, one must first grasp the concept of Hawking radiation, a theoretical mechanism proposed by physicist Stephen Hawking. According to this theory, any microscopic black hole formed at the LHC would rapidly evaporate, releasing energy in the process. In other words, such black holes would be incredibly short-lived, posing no real threat to Earth. However, not everyone is convinced. Some scientists argue that our understanding of quantum gravity in extra dimensions is incomplete. If certain speculative theories, such as those involving extraspatial dimensions, prove correct, the likelihood of black hole formation could be greater than expected. And if a black hole were to persist rather than immediately evaporate, its long-term consequences would be unpredictable. Could the LHC inadvertently open a gateway to unknown realms of physics? This brings us to another enigmatic concept, strange matter. Strange matter, a hypothesized state of quark matter, is theorized to be more stable than normal atomic nuclei. If a stable strangelet were to form at the LHC and interact with ordinary matter, it could theoretically convert everything it touches into strange matter, causing a runaway reaction. Some have even speculated that this could lead to the collapse of all matter as we know it. While most physicists dismiss this as highly improbable, the fact remains that experiments at the LHC are pushing the boundaries of known physics. As we attempt to recreate the conditions of the early universe, we are venturing into uncharted territory, where unforeseen consequences cannot be entirely ruled out. The ethical dilemma, science versus responsibility. The pursuit of knowledge has always come with risks. From the Manhattan Project to modern-day advancements in artificial intelligence, humanity has repeatedly faced the question, just because we can, does it mean we should? The LHC embodies this dilemma. It is a tool of immense potential, capable of unlocking the deepest mysteries of existence. Yet, with great power comes the responsibility to weigh the risks and rewards. Are we tampering with forces beyond our comprehension? Could we unknowingly set off a chain reaction with irreversible consequences? While CERN has strict safety protocols and has conducted numerous studies affirming the LHC's safety, history has shown that scientific breakthroughs often lead to unintended consequences. The mere existence of such concerns should prompt deep reflection. The future of high-energy physics. Despite the fears and uncertainties, the LHC has already revolutionized our understanding of physics. The discovery of the Higgs boson in 2012 was a landmark achievement, confirming a fundamental aspect of the standard model of particle physics. Yet, many questions remain. What is the nature of dark matter and dark energy? Are there extra dimensions beyond the three we perceive? Could the LHC provide evidence for quantum gravity or the elusive graviton? Will we ever achieve a unified theory of everything? CERN's scientists continue to push forward, designing even more powerful accelerators for the future. The proposed Future Circular Collider, FCC, would dwarf the LHC, with an accelerator ring up to 100 kilometers in circumference, capable of achieving even higher energy levels. But as we take these next steps, public scrutiny and ethical oversight will be more critical than ever. The LHC is not just a scientific endeavor, it is a monument to human ambition and curiosity. It represents our relentless desire to understand the universe, but it also reminds us of the fragility of our existence. Conclusion: the edge of the unknown. The Large Hadron Collider is an awe-inspiring machine, a gateway to the deepest mysteries of the cosmos. It has already transformed our understanding of physics and holds the potential to reshape our future. But as we stand on the precipice of discovery, we must ask ourselves, are we ready for what we might find? The universe is vast, mysterious, and possibly far stranger than we can imagine. Whether the LHC ultimately brings us enlightenment or unforeseen peril, one thing is certain, it is a testament to humanity's unyielding quest for knowledge. And perhaps, in seeking to understand the universe, we will come closer to understanding ourselves. Fundamentals of particle mechanics. Accelerators activate when protons are smashed together at a rate close to light speed. The amount of energy released is so great that it alters the very fabric of spacetime. Imagine a tightly stretched trampoline. Now, place a substantial weight on it, the fabric bends and curves. If the weight is heavy enough, it could create a depression so deep that anything nearby would be drawn into it. That's a simple illustration of what might occur in the world of quantum physics at the LHC, where the rules of the universe are both bizarre and beautiful. There exists a theory that extra dimensions may be hidden within our reality. If these dimensions exist, the collisions at the LHC could use them, creating a funnel of gravitation that forms a tiny black hole. This enigmatic dance of particles has even attracted the attention of notable scientists, especially the late Stephen Hawking. In his book, he warned of a scenario where the Higgs boson could become unstable when energy levels are very high. This instability could result in a catastrophic vacuum decay, a cosmic event that would not only destroy the Earth but could, in theory, consume the universe as a whole. The highly regarded British cosmologist Sir Martin Rees, an astrophysicist, also expressed his concerns about the experiments conducted at CERN. In his book on the prospects for the future of humanity, he explored the potential risks associated with particle accelerator experiments, including those carried out at CERN. His words were more than just cautionary, they were tinged with a sense of existential dread. He spoke of a worst-case scenario in which a disastrous experiment might create a state known as vacuum instability. In theory, this could cause a phase change that would ripple through the very fabric of spacetime, resulting in a cosmic calamity that has the potential to engulf the entire universe. Rees' concerns were not limited to theoretical musings. He even assigned a probability to these catastrophic outcomes, albeit a low one. But even a small chance, he argued, should give us pause. The stakes are unimaginably high, and the margin for error is zero. The scientists at CERN have calculated the odds, conducted simulations, and investigated theories to ensure the safety of the LHC. Brian Cox, a well-known physicist, acknowledged the importance of responsible exploration. Recognizing widespread fears and concerns about the LHC's activities, he emphasized that rigorous safety measures are in place, extensive procedures and checks ensure that its operations are carried out with the utmost care. Cox reassured the public that the energies involved are well within what the Earth naturally encounters, and the likelihood of developing a stable black hole is astronomically low. Even if one were created, scientists say it would be so tiny and unstable that it would evaporate in a flash of energy, a phenomenon predicted by Stephen Hawking, known as Hawking radiation. It would be a fleeting moment of cosmic wonder, a glimpse into the abyss, and then gone. Some have speculated further that the LHC's experiments could open a portal to another universe or dimension. Though largely dismissed by the scientific community, this notion has captured the imagination of many, becoming a mix of fascination, fear, and even folklore. What lies beyond our reality? Could we inadvertently unleash forces or entities beyond our comprehension? The concept of opening a door to hell has even generated sensational stories in various media, adding fuel to the fire. But what does this mean in the context of scientific exploration? The parallel dimension idea is not new in physics. String theory, a major candidate for a unified theory of everything, suggests that additional dimensions, beyond the usual three of space and one of time, may exist. These dimensions could be compactified, hidden from our perception, but in theory, they could be accessed or revealed under extreme conditions. Now, imagine the LHC as a cosmic key, unlocking doors that have been sealed since the dawn of time. When protons collide at energies never before achieved on Earth, they could potentially tap into these hidden realms. The repercussions are numerous. But, as with any frontier of science, there are risks as well as benefits. To summarize, the CERN Large Hadron Collider stands as a testament to human genius and ambition in the quest for knowledge. It is a tool for accessing the universe's deepest mysteries, but it is also a reminder of the profound risks involved in exploring the unknown. With each new discovery, we move closer to the edge of an uncharted universe, where the boundaries of science, ethics, and existence itself become blurred. The question remains, are we truly prepared for the power we are unleashing? If we are indeed standing at the precipice of discovery, what might the next steps be? As humanity continues to push the boundaries of physics, we must also grapple with the philosophical and ethical dilemmas that arise. The ethical dilemma of high-energy physics. Science has always been about pushing limits, but at what cost? While the LHC has produced groundbreaking discoveries, such as confirming the Higgs boson, it also raises existential questions about the nature of reality and the possible dangers of experimentation at such extreme energy levels. Some scientists argue that pursuing knowledge is inherently worth the risk, that humanity's progress depends on daring to explore the unknown. Others urge caution, warning that even the most advanced calculations may fail to predict all possible outcomes. History has shown that scientific progress often comes with unintended consequences. The discovery of nuclear fission led to both nuclear power and nuclear weapons. Could particle physics follow a similar trajectory? Could an unforeseen event, no matter how improbable, one day threaten more than we anticipated? The quest for the grand unified theory. At its core, the LHC is searching for something deeper, a grand unified theory, GUT, that would reconcile the fundamental forces of nature. Currently, physics is divided into two major frameworks. General relativity, which explains gravity on a cosmic scale. Quantum mechanics, which governs the behavior of subatomic particles. These two frameworks, while incredibly accurate within their respective domains, are fundamentally incompatible. A true theory of everything would merge them, revealing the hidden structure of the universe. One of the most intriguing possibilities is that gravity itself may be linked to extra dimensions. String theory suggests that our universe could be part of a vast multiverse, where different dimensions interact in ways we have yet to understand. If experiments at CERN provide evidence for such dimensions, it would revolutionize our understanding of existence itself. Are we on the verge of a new era? Every technological breakthrough brings both excitement and uncertainty. The LHC has the potential to unveil secrets that could change physics forever, perhaps even answering the deepest questions about the origin of the universe. But it also serves as a reminder that scientific discovery is not without consequences. As we venture further into the unknown, we must ask ourselves, are we prepared for what we might find? Do we fully understand the risks? If we uncover forces beyond our control, what will it mean for humanity? The LHC represents the pinnacle of human ingenuity, yet it also reminds us that the universe remains vastly mysterious. Whether it leads us to a new golden age of physics or forces us to reconsider our place in the cosmos, one thing is certain: our pursuit of knowledge will never cease.